Right, so my name is Paul Nadir. I'm the Managing Director here at Syntec Engineering, and I've been working with Apex for quite a number of years since they introduced this new product range at MSC in 2014. Before we start with our session, I'd like to draw your attention to the Sharpen The Saw meshing series that Gerrit Visser presents. His next session is on the 12th of March at 12:30, and he essentially covers the why of CAD Clean-up and why we need a quality mesh, etc. And then in the next session, we haven't finalized the date yet, I will handle how to do some of these mesh preparations in MSC Apex. I've shown some examples here of a refined TET mesh as well as a hex mesh of a quite complex part, and we will deal with how you can prepare your CAD for that. But on the agenda for today is specifically focusing on CAD cleanup. So if you Google Syntec and the number 18, you will find this blog where I've covered why Apex is an award-winning product, and there's some references of numerous case studies that customers shared on how it has speed up their mesh preparation process. So we will essentially cover all these tools on the screen in this form, in the geometry edit form. And what I want to highlight to you, specifically if you're a new user to Apex, to just hover your mouse for a second on any of these tools, and then a help video will display. It's normally very short video, maybe just a few minutes or not even a minute. You can alternatively click on this little document icon, and it brings up all the multimedia that comes with the installation, like animation or movie, the actual document, or images that relates to it. So there's a lot of help built into your user interface that you can access all the information on. We'll essentially just cover the split tool briefly, just as a matter of, well, I need the functionality in one of the demonstrations. We will take care of this in a lot more detail later on in the next session when we discuss mesh preparation. Midsurfacing I'll use briefly as well, but we're not going to go into all the detail, but this is a very useful tool that you will probably use a lot. Vertex Edge Drag is the first and foremost tool that we will cover, and this is extremely useful on mid-surface representations of analysis models. But as you'll see, that the Vertex Drag option is now also supported on solid, so you can actually fine-tune or remove small little defects in your solid using this tool, and I'll showcase some of that. The split surfaces tool is also a function that is very handy in many cases, and one of the aspects that people don't always realize is that you don't need reference geometry to be able to split surfaces. You can do it on the fly, and that is what I'll be showcasing, as well as how you can get rid of these internal features or edges by simply deleting them. The filler tool is actually designed to fill holes with or any closed looped edges of geometry, but you can also create new surfaces using it, and not everybody is aware of that, so I'll be showcasing that. The Add Remove Vertex option is very handy to remove large numbers of vertices on edges in one go. And that typically removes only vertices that are redundant and aren't necessary to define the edge geometry. I'll skip stitching and split curves. We don't use that too often. I'll focus on the tools that we use more often or all the time. So the push-pull tool, very handy tool to remove gaps or overlaps. Zach, can somebody just mute some of the other participants? Thanks. Right, the Revolve and Sweep tools that are available, I'm not going to demonstrate today because that could also be a potential lengthy session. So I'm just showing some examples of what can be accomplished using the Revolve and Sweep options, but there are a lot of information and details and options in there, so I'm not going to cover that. So I'm just mentioning that. Then a feature that you use quite a lot on both solids and surfaces is the defeature tool, and then specifically for surfaces we have this option to defeature unique features, and I'll show you a number of examples on that. Suppressing and unsuppressing is also very useful when the base geometry has too much detail and it refines the mesh unnecessary. So I'll showcase that. Then I'll skip to geometry cleanup. It's actually the tool that you're supposed to use first. In a lot of cases that can resolve a lot of issues that you have when you try to prepare a FEM. And yeah, this tool is very handy to find small defects or unique defects that would definitely influence the quality of your mesh. All right, those are essentially the tools that we will be covering in a moment, and we'll come back to this article as shown over here. Right, so for this demonstration, I'll be importing a few assembly files, and we will prepare them for cleanup. All right, so as I stated before, going back, the first task is how do you get more information on any of the tools. So whenever you simply leave your mouse for a moment, literally a second that you just need to hover the mouse, this little help window opens up. You can click over here to go to the documentation or go directly to a relevant video that shows you more information of that particular tool, or you can click on the little document, and under documents or over here you'll actually see HTML complete document with more information and sometimes more detail than in the videos. So that is a very handy resource for you to use. Also, whenever you use a tool, by default, this workflow instructions are hidden, but you can expand that. There's always a number of handy keyboard shortcuts to know of and understand what they do, because they can actually simplify your life quite dramatically. All right, so to start, I'll quickly demonstrate the Midsurface tool on this particular assembly. So let's just show only this guy. Midsurface tool, the default is the manual method. I always skip to the second one. This works fantastic for constant thickness solids. So like in this case, we have a number of plates that represent parts of a constant thickness. You simply select all the parts and it's automatically executing your task, and it also assigns your thicknesses directly. So if we hide the solids, we now have midsurfaces that represents those parts. We can mesh them in one go. Sorry, I see I missed a few on that side. So let's just mesh that again. So there we have surfaces that now represents the original solids, and we can assign a material or quickly create your library of materials using a little script if you like. And I'll just assign my steel to these guys. Now these plates are not connected yet, And for those of you who use a lot of bolt connections, you might like this little script that comes with your latest installations. It's a script that Larry Pierce wrote, one of the pro Apex users. It's actually accessible through the Python coding. You can simply select setup settings over here, define everything that you want connected. It automatically goes and finds all the holes for you, and it creates connectors between the different plates. Right, in this case it seems there's an error. This is obviously always something that happens. While this was working perfectly before, this isn't now working, and I am not sure why that is. Bolts, rigid, still, don't know, I don't think that normally worked unless the holes are a bit bigger. No. Okay, it's not our lucky day. All right, it is not standard functionality that comes with Apex. It is a little script, so little issues like that might occur. Not sure why this now didn't want to work like it did previously. Okay, so that was just a quick one on mid-surfacing and assigning your materials. Right, another tool that is quite handy to understand about the user interface is that everything on top here is purely manipulating visualization. There's no physical tools that have any special functionality other than the ability to hide surfaces, solids, etc. So for instance, in this case, we can now quickly only hide that, only show our tank. And what I want to do with the tank is work with a quarter model. That speeds up the whole cleanup process, obviously, because the full complete model is symmetrical in two directions. So if we split this, let me just split it with that fashion. And I'll select a middle here. And if you noticed, anytime you hover your mouse for a moment on any feature, there's a little white dot that appears. That is the absolute middle. So you don't have to find or know exactly where the middle is. You can find it on the fly. And now we have a model where we have everything split nicely in half. So I'm just going to delete this half and work on this half to showcase some of the tools that we want to show. So I'll again quickly generate the mid-surface using the automatic thickness for constant thickness properties. And there we have it. So now we have shells and solids assigned with their thicknesses. Right, so the first tool that I said I'll be showcasing is the edge and vertex drag tool. So let me just go back here. There's a mid-surface. So in a case where you have surfaces that should connect and they don't, we can use the edge drag tool. So this is a good example of two plates that do not connect or have rather dirty geometry in this area. Now, if a mid-surface looks like this, it's always as a function of the original surface or the original solid that you have in this model. So if we showcase the solid that was used to generate this mid-surface, we see that it had a number of dirty features over here. Oh yes, and there's another thing that I'd like to bring to your attention. The default graphic settings is meant for screen cards that aren't that strong. So if you have a proper screen card in your machine like I have, you can increase the tolerances for the curvature displays. And you simply do this under Options, Application Settings. And what you will see in a moment is these curves disappear and being replaced by a smooth curve. So you simply switch this to fine or very fine. With a large model, I don't recommend very fine, where it might be a bit taxing on your screen card, where fine is normally good enough. So here we can see now there's a smooth representation of those curves. All right, so when we already have our mid-surfaces and we don't want to revert back to fix the problem in the solids, we can use our edge drag tool to either drag and extend edges or vertices. Right, so there's a lot of things that we can do to improve the quality of a structure like this. Another example, for instance, is one little defect that I am aware of. And this defect that exists in this mid-surface is actually as a function of the original solid that had a defect in there. Now, unfortunately, you typically don't know about these until they start giving you a problem. So, for instance, when you get to the point where you mesh this body, you will get bad elements. Or maybe you'll notice that there is something fishy in there, but it's so small you might literally not even see it. And only when you try to analyze the model will you actually find that there's a problem. When you have a lot of those, it can be a headache to find them. And this is where the CAD geometry cleanup tool comes in really handy. First of all, by just simply cleaning the CAD, you can resolve a lot of problems. But secondly, this option is of immense value. To find, let's say, anything smaller than 2 millimeters in this large model, we simply select everything that we want checked, middle mouse click, and it gives you a list of small features that are within that tolerance range. And immediately it highlights this problem area. And we can zoom in and find, okay, there we go. There's a little spike. So any feature that looks like this, it regards as a spike, and this is obviously causing us a problem. In this case, the short edges are shown in the exact same area, so we see one defect actually caused 3 defects. So using our edge drag tool, this is a very easy fix. We just drag this edge and snap it to that edge, and immediately our defects are gone. And if we refresh, we see that there's no defects anymore, and our mesh has properly updated along with it. Okay, so that was in short the edge drag or vertex drag, and just to show that it now works on solids as well. If we only look at this horrible solid over here, we see that there's a few things that doesn't make sense, and if it's a small thing that you can fix using edge drag like this, you can now vertex drag, you can do this, but be careful, sometimes the resulting shape might not be exactly what you expect, but this is something that you can experiment a bit with. All right, so we will come back to fix this using a different tool. Just want to jump back to the slide. Okay, so the next tool up is the split surface tool, which is a tool that can be used on both surfaces as well as solids. So if we look at a structure like this, for instance, we have a number of tools that we can manipulate the geometry with. You've now seen the ability to drag a node like this, but we can also drag edges. For instance, using the push-pull tool, we can drag an edge, change the volume like that. But that obviously affected that whole face. If we just wanted to make a small change, we can use the split tool on the face or surfaces. For instance, in this case, we identify the face that we want to split, and just by dragging along on the screen, pick two locations, and now we have a new split, which means if we were to use that same tool, now we have a totally different effect, or we have a smaller face that we can push and pull. Now, this is not only for solids, as I said. This can equally be useful for surfaces. And there's a number of reasons why you would want to split a surface. Sometimes it's to define different thicknesses or different properties, or maybe apply pressure to a smaller region. So now we can simply pick a few locations over here, and hopefully it split it the way we wanted it. Now this one doubled up on top of itself, so it didn't exactly go the way I wanted, but I can simply move back to any tool that gives me the ability to drag or select edges. Now edges can be dragged, as mentioned before, internally as well, or we can simply right-click on them and delete them. So we see that these unnecessary edges can easily be deleted or be dragged into a new position. Or if we have a split that we didn't want in the first place, we can also select all of that and simply delete it. And in that way, also get rid of splits that we don't want. For instance, when the mesh quality is impacted by that split and you don't really need it for anything else, it's a nice way of getting rid of it. Not all internal edges can always be deleted, like these defining edges over here can't be deleted because they literally define the transition from a flat surface to a fillet surface. But it's worth a try in instances where you don't need them or don't want them. Okay, right. So that was the split surfaces tool, which can be quite useful. The next one is the fillet tool. Now, as I said, the fillet tool was originally designed to fill holes with, or any open areas. So there's a little hole and we can fill that hole, or if there was something larger and it didn't need to be necessarily be a hole per se, it could have been something not like that maybe. Let me just add another vertex, see if I can break this geometry a bit. Maybe use one of the other options. Let's just collapse that. Maybe use that tool. This could be an option as well. So I'm trying to break it a bit. Okay, so if that was something that you needed to fill, the filler is by default developed to fill features like that. But what I want you to notice is this lightning bolt. Now this is the auto apply or auto execute option. If you switch that off, you have the ability to progressively pick entities that you want to fill with. So for instance, picking those vertices and those fillet surfaces, I've now literally in a matter of seconds created something new. And obviously this is some detail that we may probably not want. So we can use our features like this to get rid of these features that we don't want. So we can easily create a new part like that, or get rid of these little details. We can also sometimes, if feature drag doesn't work, try one of these alternative methods to drag and drop curves out of existence. And as you can see, many ways and many options you have to manipulate. And this is all in service of getting a better mesh. What is a very handy tool to use is actually to mesh your part, but you can actually mesh it with a very coarse mesh. A coarse meshes updates much quicker, and they also tend to show you defects much better. So this is not intended for the actual analysis, but it does show me that there are certain things like this little hole there that will adversely affect the quality of my mesh further on, even if I use a smaller mesh. So this is handy to see where there might be problems. Okay, we'll come back to this tool. The next tool that I want to showcase is the adding or removal of vertices. Now, normally we simply use this to divide an edge, for instance. So for instance, if I want to divide this edge so that I can match this mid-surface to this one, adding vertices is a useful way to divide this edge so that I have a shorter section that I can simply snap this one to. And you see it has now actually even moved that plate out of plane a bit to do this match. Okay, so that's one of the tools, but often we sit with a CAD that we receive from somebody else, and depending on how they created the geometry, you might sit with little features that can't be ignored by the mesh, regardless of the mesh quality or mesh settings that you use. Those vertices always enforces a node at that location. And if this is the way that you receive them, it might be a lot of work to individually remove all these holes. Nothing stops you to literally activate the tool and drag it over the whole model, regardless of what it is. And it will only remove the unnecessary ones. And we can check the progress over here. And at the bottom over here, we can see that it actually removed 487, much more than the ones that I've removed over here. It actually removed elsewhere in the model that had no purpose. In other words, they were on straight edges, and it didn't change the geometry at all by removing them, but it will make a huge improvement on the actual quality. Okay, so that is why the add remove vertex tool is of use to a large degree. Right, so now we skip over to the push-pull tool. And this one is of immense value when working with solid models. We've seen in this original model, let me just show the tank only and hide the meshes as well. Okay, so if I maybe just show these, oops, just want to show these ones only. We see that these solids were not properly modeled from the CAD side, and if this was a model that we wanted to solid mesh, it would obviously not work because they don't have anything in common to connect with one another. So a nice tool to use is the edge drag tool. The face pull tool. So by default, we have the option to simply just pull faces into a specific direction. Okay, but that's not really what we're after in this case. What we're actually after is this important option, the up to option, where we take this face and we say pull it up to that one. And what it now does is it does a perfect extension to match the other solid at the other end. Okay, we see that those remaining faces did not do a good job. And then you have to take care of looking at these other options, because that might actually affect the end result. So let's try that again. And that creates a different result. So it might be better if we first hide these solids and get rid of these unnecessary features first. So again, we could either remove them using our defeature tool like that. And what that does is it looks at the logic of remaining faces and see if it can find a logical solution if we're essentially deleting this face, but it can't leave a hole in there. It has to be able to extend the remaining faces to get to a result like that. Okay, so that was definitely one way, but in this case, that doesn't make those two faces match yet. We actually see that the one is now penetrating the other. So that's not really a problem. There's another very handy tool, and it's also shown in here, and this is the H key shortcut to hide pre-selected faces. Now, a pre-selected face is one that highlights whenever you are in a tool, for instance, like this tool that needs to select face. In this case, this is a pre-selected face. Now, I have the ability to look inside my solid, and I do that by pressing H. And I can actually see what's going on the inside, and in particular, I want to see inside this solid so that I can grab this face over here. So this is a very handy tool, and I want to pull this face now over to this solid. As you can see, a portion of it is on the outside and a portion of it is on the inside. By using the push-pull up to option, I can now push it and pull it, and it makes a perfect match. So now these solids are closely in relation to one another. So if I were to mesh them, these solids are touching. All right, so that's the push-pull tool, and we will use that a lot, as I said. Okay, I'm not going to demonstrate the revolve and sweep tools. That takes more time, and you can experiment on your own there. The next tool that I want to showcase is the defeature tool. Now, you've seen the defeature tool in action on the solid, and there's a number of other features in here that we could get rid of as well, one by one if we wanted to, like these holes, maybe like those fillets and radiuses, things like that. But another function that it has is what we will see over here. If I showcase my solids, these particular surfaces. Now, manually, you can go in. If it's a closed loop system, you should be able to just select one edge and it cleans up the whole thing. In this case, it's battling a little bit more because these edges don't really form a closed edge. But if we switch off the automatic selection and select these, we can try and select it. In this case, that didn't work either. So then your only solution would be to use the edge drag tool to get rid of it. Okay, but that's only fun up to a point, and if you have hundreds of these to do, it's no fun anymore. So we have the geometry defeature tool that can identify features, set features. Like in this case, we can identify all the holes and sometimes fillets. Now, I don't have fillets or chamfers in this specific case, but if they were, they would have highlighted over here. So what this has done, it has identified all the two-dimensional holes, even on this double curved surface. Okay, and it has automatically grouped them into two ranges between 20.17 millimeters in diameter and 9.59. Now that's not fixed. This is a adjustable range that you can adjust over here. You can also drag it all the way to the top, and it then removes the second category, and now there's only one group. Or you can selectively select anywhere over here or edit the values and create new groups. Now this is handy if you only want to remove a certain range of hole sizes all at once. So you select them, it turns orange, and orange means that if I now middle mouse click, the selected entities will be removed. And as you can see, they were removed on all the faces. Now, if you just want to remove all of them, you simply select it in this manner, and there you go. All those holes are removed. Okay, but those only selected or pre-selected standard features like holes, and on solids it will also select fillets and chamfers. What about all these others? Now these are non-standard features. For them, we can teach Apex how to define them. We have a length tolerance and an angle tolerance. So if I select one of these, let's say this short one, and what I'll do is I'll use the shortcut Alt and double click to select all the adjacent edges. It has now learned what is the shape that I want to remove, and I select everything that I want to remove it from, middle mouse click, and now it shows me all the similar features that it has identified. And obviously you can see these ones haven't been identified, and these longer ones and this one at an angle also wasn't identified. That's purely to do with the fact that there's a length difference between this shape and that shape, even though the shape's the same and the same on that side over there. So if I go back and I change this length tolerance, let's say to 200, and let's make this 50 degrees, and I do the exact same thing, middle mouse click, select the surfaces. Now all of a sudden you see all those features have been selected. The only one that hasn't been selected is this one that's still outside the boundary. I can middle mouse click, and all of them have been removed all over the model wherever I selected those. And if I want to select this one manually, I can do so. And they are gone. So just to repeat the process, this time I'll use this as an example. So we see basically the same shape cut out, but over here we sit with a shape that looks like this. It's defined by two edges with a curve in the middle, and it automatically picks up all those. Now be careful. You may not want these ones to be included. So you may or may not want them. But as you can see, it has automatically identified the same shape. But that wasn't part of the shape. So that's why that wasn't included. Now this may or may not remove the hole. So you have to be careful. You can deselect them if that's something you want to do, or maybe you want to retain that one over there. Middle mouse click. Let's see what happened. Okay, no, I didn't remove those ones as I wanted actually. I can go ahead and remove those by redefining them through just clicking the selection of edges that defines that new shape. And now you see it has found them, and I can remove them. Okay, so here's a few of these that didn't go along in the previous group. Let's see, it finds them, middle mouse click, and they're gone. And you can continue doing this for all these other parts, but I hope you get the idea. And obviously this now severely improves the mesh on this on these bodies, as you can see where those features have been removed. And maybe let's just do it in any case, quickly get rid of these guys. So what the process is, you check on that box, go there, accept that shape, remove that, and there you see all those are gone. And lastly, you can do the same for those. Okay, all right, I think that's hopefully clear enough. Okay, the next one is how to temporarily ignore certain features in the geometry. So this is what we call feature suppression. So if I look at my composite panel over here, I see that there's a lot of features that came through from the CAD system. And if I mesh this, even with large elements, I will have all these small little features that are enforced, and you can't ignore them unless you use this suppression feature. Now this is handy if you want to just do one feature at a time, or you can do a lot of them at a time. And in one go, we see that a lot of features, now this one was reversed, a lot of features were suppressed. But strangely, there's a ridge over here where the plate changes its shape quite drastically that it didn't suppress. And for some reason, it doesn't suppress it, even if you put it on suppress only mode like that, those stay. Okay, but that has to do with a little tick box over here. And this I've only found out recently. If you untick that, it's actually much more aggressive in how it will suppress features. But now, as you can see, my mesh can literally take a shortcut, and that is probably not what you want. So you can reverse the process by simply, again, selecting contiguous edges. The shortcut is Alt double click. And there you have that. Missed this little one there. Okay, and now you have that feature retained. Or if you wanted this to be in line with that, you can still just edge drag it like that. Okay, so that helps us a lot to improve or manipulate rather the element shapes and qualities. I don't like all those tries, so let's just redo that with a proper quad mesh. Okay, so that was suppression. See, we have 15 minutes left. So now we get to CAD Clean-up. This I've actually shown before. I don't have this particular model, but this is one of the tools that you shouldn't disregard. The ability, now let's just show the big model again. This ability to identify small features in a model, of course you can increase that a lot. So there it has now actually found this slither. Oh yeah, before I only cleaned up the mid-surface model, I didn't have this, had the solids visible. So now it actually shows me that there's a little defect in my original solid model that I wasn't even aware of. And this is very, very useful to know. So now I can come in, let's just get rid of that feature and see if we can delete that. Right, so now this is done and we can jump to the next one. It automatically zooms in if you have that open. So let's see what this was all about. Oh, right, there's a small little chamfer in our model that we might not want, or maybe we're fine with that. Let's see, where's this slither? Slithers are normally quite bad. It adds a lot of problems in a model. So it looks like it is on the surface. So there is a small, no, it's not on the surface model. It's actually on the solid model. Okay, so it looks, okay, it's highlighting that little feature there. Again, so here we see two solids that are not facing, probably because the original CAD drawing is leaving a gap for welding assembly purposes, but obviously if you run a finite element model, we can't live with that. So one way is to just get rid of the chamfers first. I can put it back on automatic, get rid of that, and use our push, pull, and up to tools to quickly get rid of those ones there. Okay, there's obviously a little offset there. Depending on what the purpose of your analysis is, you may or may not want to get rid of that. Okay, so that is how to find small little defects in your model, as I've shown over here. You can also find gaps and overhangs and small edges. This works on different kinds of technology, geometries. And another one that should actually be the first option in many of your CAD operations is the one to identify if there aren't any defects in your solid. Now, in this case, there aren't any. But I had a case recently. In fact, if I remember correctly, it's actually this model. If you import it the first time. So let me quickly import this tank again from scratch. And if I don't switch on the CAD Clean-up, so by default, CAD Clean-up is on, so it automatically fixes defects. If I remember correctly, this one actually comes in with a defect. It seems they've actually improved the defaults as well. Okay, so it's sometimes really difficult to show examples of defects because you never have them when you want them. But that is where that tool comes in really, really handy. All right, so it seems like there's 10 minutes left. I've run through the examples that I wanted to cover. Just to remember, this is a very useful summary of a lot of these features with some case studies as well, where companies have found it extremely powerful to speed up the process to clean their CAD for analysis. And here's some summaries of some of these potent tools that you can use, and some of them that I have covered. So this is a handy reference to go through. So in the next session, well, the first session is Gerrit's session on the 12th of March that deals with meshing per se. And then at a later date, keep an eye out for our emails. We will discuss and show you some of the tricks to manipulate meshes, specifically solid meshes, to manipulate them on geometry level prior to meshing, so that you get the quality and shape of meshes out that you actually want to get out of your system. So we actually have time left for any questions, if there are any. So you're more than welcome to unmute yourself or use the chat box if you have a question, or if there's something you would like me to show or explain in a little bit more detail. Yes, I see there's a hand. JD?
Yes, good morning. I saw that you had a little window for the macros that you said is included in the latest installation. It's on the right-hand side. Is that something we should activate, or?
On the older versions, you had to activate it. This comes pre-activated with the latest version 2021. So if you have Apex 2021, this will be there by default. If you run an older model, there is a way to activate it, and I can share with you those steps. But I would recommend installing the latest version, because there's quite a lot of new things in this version.
Thank you.
Good. It's just Paul at simtech.co.za. More than welcome to mail me or any one of the team on our support portal, support@simtech.co.za. All right, thank you everybody for joining. If there's no more questions, as I said, you're welcome to email me.